to this, the fifth of our programs on the basic ideas of physics. Now, you may remember that in program 4, I talked about energy. I talked about the different types or the different forms of energy. Well, in this program, I want in particular to look at converting energy from one form to another form. You'll remember, just like converting different currencies into other currencies. Now, I want to begin by talking about the source of all our energy on Earth. And the source of all our energy on Earth comes from up there, from the sun. If the sun were to go out, the Earth would die. All our energy on the Earth comes from the sun. But the amazing thing is, do you know what the sun is? The sun is a giant, absolutely enormous, giant nuclear bomb. That's what the sun is. The sun is a hydrogen bomb, exploding continuously, consuming millions of tons of hydrogen in its nuclear explosion. Notice, the hydrogen isn't burning, it's a nuclear reaction. So the sun gets its energy from a nuclear explosion, nuclear energy. How does the energy get from the nuclear bomb up there in the sky to us? Well, it comes as electromagnetic waves through the vacuum between the sun and the Earth, traveling at the speed of light. These electromagnetic waves come, we call it radiant energy, and they give to the Earth heat and light. And we depend on the sun for all our energy. One of the new ways that we can get energy from the sun is by using the heat energy that comes, infrared radiation. And one new device coming into Bhutan now is a solar water heater. These tubes here are specially designed to absorb infrared radiation, heat radiation from the sun, and cold water flows through these pipes and it gets heated up, and if you feel this, it's cold, but if you feel that and this and here, you've got hot water. Radiant energy from the sun turned into heat energy. And if we have a little look around this garden, which is actually the garden of Bhutan Telecom, we look at the grass. We look at a tree. The tree has green leaves. Radiant energy from the sun, from the nuclear bomb up in the sky, radiant energy from the sun creates a thing called photosynthesis, and the radiant energy from the sun is turned into all the nutrients that the tree needs to grow. Photosynthesis. So we owe all the green grass and all the green trees around us to energy from the sun. Another place where we have chemical energy is in plants. And green plants like these, they use energy which is coming from the sun, radiant energy. They use energy from the sun in order to cause a chemical reaction called photosynthesis. And that allows the plants to take carbon dioxide from the air and turn it into sugar in order to give the plants energy and food to grow. So there in green plants, we have got a very good example of stored chemical energy there. And we have that to thank for all the greenery around in Bhutan. When we say keep Bhutan clean and green, we remember it's photosynthesis and chemical energy in the plants that keep the country green. We owe life on Earth to the sun. Without the sun, the Earth would be a frozen planet with no life on it whatsoever. Now, I said, talking about conversion of energy, I said all our energy on Earth comes from the sun. The other fact to know is this: all energy that we use on Earth ends up, in the end, as heat energy. It may go through a series of changes, but it ends up as heat energy. The sun helps create the chemicals. The chemicals may go in a battery or be used to produce electricity. The electricity may be used to light an electric light bulb, which gets hot. All energy used on Earth ends up as heat energy. So remember those two rather strange facts. The sun is simply a giant, very giant nuclear bomb. The sun gives us all the energy that we get on Earth, except for, there's one exception, and that is nuclear energy that we get from uranium in the Earth. The nuclear energy we get from uranium in the Earth was created when the Earth was created. That does not come directly from the sun, but all other energy apart from nuclear energy from the sun. And the last, third point, all the energy we use on Earth ends up as heat energy. Now, we'll go and talk a little bit more about some of these conversions. First of all, let's go and look at a way of converting the radiant energy of the sun directly into electricity, a solar cell. And all around Bhutan you see solar panels being used to generate electricity. In the valley of Phobjika, every house has got solar panels to create electricity, low power electricity, for powering bulbs and this sort of thing. Let's look at a solar panel. So this is another way in which we can convert the radiant energy which comes from the sun into something very useful. This is a solar panel. It's very good in Bhutan because the radiant energy from the sun in Bhutan is very strong, very powerful. This is a solar panel, and all these little black things here take radiant energy from the sun and they turn them into electricity. And then we can connect this to a battery and we can store the electricity there. Well, I've already told you in the last program, we don't actually store electricity in the battery, we store chemical energy. So if we think of the conversion process, the sun is a nuclear bomb. Nuclear energy, as the sun explodes, produces radiant energy, which comes to the solar panel and is converted into electrical energy. The electrical energy goes into the battery, where it is converted into stored chemical energy. So there is an energy conversion chain: nuclear, radiant, electrical, chemical. And we can then, when we wish, use the stored chemical energy in the battery to turn that back into electricity again. The solar panel, you'll see more and more of these coming on houses all over Bhutan, saves your electrical bills. In the valley of Phobjika, every house has a solar panel here, and it provides just enough electricity to light electric light bulbs and simple basic electrical equipment. Right. Now, this whole business of converting one form of energy into another form of energy is really important. It's fundamentally, it's the basis of all our society, our technological society, our agricultural society, our life on Earth is all about converting one form of energy into another. And as things become more technological, what we really mean is we're developing new and more clever ways of converting one form of energy into another form of energy. Now, here we are at an electrical store in the middle of Thimphu. Let's go in and look at one or two devices for converting energy that we might find in a shop like this. This shop sells all sorts of things that take in electrical energy and give out other sorts of energy. Let's just look at these flashing lights here. We feed electrical energy in and we get light energy out. Let's look at an ordinary light bulb. We feed electrical energy in and the bulb converts it to light energy. But one of the problems with a bulb like this, an awful lot of the electrical energy that we feed in doesn't come out as light at all. Something like 85% of the electrical energy we're using is turned into heat energy. And if you've ever tried touching a bulb like this when it's a light, you'll burn your fingers. So there's a lot of waste of energy here. 85% of what we feed in and what we pay for as electrical energy just gets turned into heat with a bit of light. Now, we've got a more developed, a more clever bulb, which is the bulb that looks like this. This is a highly efficient bulb because instead of 85% of the energy turning to heat, in this bulb, 85% of the energy is turned into light. And if this bulb is lit, you can actually touch it very carefully without burning your fingers too much. So this is why a bulb like this is more economical to use. You have a smaller electricity bill. It uses less electrical energy to give out a certain amount of light. The old style bulb, the new energy efficient bulb. We want bulbs to produce electricity. This is more efficient at producing electricity than this. Let's look at another energy converter that we'll find in a shop like this. An electrical heater. Now, this is called a radiant heater. Why? Because we feed electricity in, and this device converts the electricity into heat. Now, some of the heat you can feel, it heats the air. But some of the heat from this is actually turned into infrared rays, radiant heat, and it shines out forwards. And this sort of heater is jolly good for making toast or for warming your hands in front of. Another sort of heater turns the electrical energy into energy that heats up the air, a convection heater. I wonder if they have one of those here. So this heater produces a lot of radiant energy, infrared waves, electromagnetic waves, whereas this heater heats up oil inside here, which heats up the metal veins, and this goes to heat up the air. Again, electrical energy fed in, here, heat energy coming out there, another energy converter. Here's another example of electrical energy being turned into light energy for decoration purposes. But again, with these sort of bulbs, the majority of the electrical energy you feed in is actually turned to heat energy. and it's wasted going to heat up the air. Thank you. All very pretty, but they make a lot of heat, waste a lot of your money that you pay for the electricity. Here's another energy converter device. We feed in electricity, electrical energy, and we get out kinetic energy when the drill turns around. An electric motor in here which converts electrical energy into kinetic energy, into movement energy. But unfortunately, it also produces heat. Some of the energy I pay for to feed into it as electricity actually just goes to heat up the environment. And you remember I said earlier, all energy on the earth ends up as heat energy eventually. So an electric drill, converting electrical energy into movement energy and heat energy. And the heat energy is wasted. We're all familiar with, which turns electrical energy into other forms of energy, is the television set. And what does a television set do? We plug it into the mains, we feed in electrical energy, and what do we get out? We get light and we get sound energy. Light energy and sound energy. But once again, some of the energy that we feed in comes out as waste heat energy. The television set gets hot. So a television set is a converting device which converts electrical energy into light energy, sound energy, and heat energy. Well, now, I said with the television set we get heat energy which is wasted. Why? Because we actually don't turn on a television set to heat our room. We'd use an electric heater. Similarly with a light bulb, you don't turn on a light bulb to heat the room. What you want from a light bulb is light. That's why the heat energy is wasted energy. But here's a device where actually what we want is heat energy. We plug it into the electrical supply, we feed in electrical energy. This gets hot. We want it to get hot because we need it to be hot in order to iron clothes. So the heat energy that comes out of this is not wasted energy, it's useful energy. Some devices, we want heat to come out. Other devices, the heat energy is wasted energy. So when looking at whether energy is being wasted, we need to work out what the purpose of the energy conversion device is. The electric iron, the purpose is to generate heat. An electric heater, the purpose is to generate heat. A circular saw, connect it to electrical energy. The saw blade rotates very fast and it's very useful. What we want from this device is not heat. We want the blade to rotate with enough force to cut through a piece of wood. So this is a device, and what we want out is kinetic energy of rotation. Unfortunately, the electric motor will get hot, and so in this device, the heat generated is wasted energy. So always remember, what is the purpose of an energy converting device? All the energy I get out which is useful for that purpose is good. Heat energy generated, if I didn't want it, is wasted energy. Now, the electrical heater is an energy converting device. We feed in electrical energy and we get out heat energy. Now, the point about a heater is we want the heat energy. It is the heat energy that is the useful energy. Some other devices, like the electric saw, we don't want heat energy, we want rotational energy of the blade. But unfortunately, we always get some heat energy. We have to ask ourselves, what is the purpose of an energy converter device? And then we can work out where the wasted energy is. A heater, the purpose of the heater is to produce heat energy. The purpose of a light bulb is to produce light energy. The purpose of an electric saw is to produce rotation of the saw blade. Identify the purpose, and then you can decide what is waste energy and what isn't. Now, if we think about a motor car engine, there's an energy conversion device. It converts chemical energy in the petrol into kinetic energy of the car. That's what the internal combustion engine does, converting chemical energy to kinetic energy of the car. It's kinetic energy of the car that we want, but as you probably know, the car engine gets hot, and that is wasted heat energy. We don't use that to help the car move along. What we actually want from the car engine is kinetic energy. Well, now, here I've got a very, very useful energy converting device, a microphone. So what goes in and what comes out? Well, what I feed in to the microphone is sound energy, and this device converts the sound energy into electrical energy. And I can even go backwards. I can convert electrical energy into sound energy. But to do that, I need another device like this called a loudspeaker. So sound turned into electrical energy in the microphone, electrical energy turned into sound energy in the loudspeaker. Two complementary energy conversion devices. So here's another energy conversion device, an electric guitar. And this turns the vibration or kinetic energy of the strings into sound energy, but it does it first of all by turning the vibrations of the string into electrical energy, which comes out here, into an amplifier, and then that produces sound energy. So the electric guitar, kinetic energy of the strings, turned into electrical energy. Electrical energy feeds into a loudspeaker, and we get sound. So here we are at Dolmer Enterprises, and we are looking at a very different sort of energy converter device, a refrigerator. Now, we feed in electrical energy, we put the refrigerator into the mains, but what sort of energy do we get out? It doesn't get hot in here, it gets cold. But there's no such thing as cold energy. So what actually happens with a refrigerator? Well, we feed in electrical energy. The electrical energy turns an electric motor, and then by very clever science inside the fridge, the electric motor pumps heat energy out of the inside of the refrigerator. Where does it pump it to? Well, if you look at the back of a refrigerator, you'll see there's a sort of whole set of pipes and cooling vanes. And the electrical energy turns an electric motor, kinetic energy. The electric motor pumps heat energy from here out to the back, and then the heat energy disappears in the air. And so the inside gets cold. So that's a rather different sort of energy conversion than the straightforward ones that we looked at a moment ago. The refrigerator.